Hi, ladies and gentlemen. How are you guys? I'm doing alright. Alright, so teleportation has been demonstrated for the first time ever. This is beyond where people are sending photons and stuff like that. This is real-time information and everything else, and this is basically the idea. A group of researchers led by, I don't know how to pronounce his name, Semite, and his group have been verified as the first in the experiment of the conception of teleportation to prove teleportation in the world of quantum particles and quantum mechanics, but also in the classical world. Smizit and his associates reported this in the Lasers and Photonics reviews. The distinct form of laser beams in the experiment, done with the physical states of elementary particles. The properties of light beams can also be entangled, explains Dr. Marco Ormagato, member of Professor Zemet's team. Basically, using entanglement, they were able to take the particular property of the light, and basically from this, the group of researchers led by this guy first time verified an experiment that the concept of teleportation does not only exist in the world of quantum particles, but also in a classical world, in the real world. I'll get into how they do it in a second. Now, in this actual experiment, ladies and gentlemen, the physicists have encoded some information in a particular polarization direction of the laser light, and actually transmitted the information to the shape of the light beam using teleportation. With this, the form of teleportation, basically, Seismic said, we can, however, not bridge any given distance, admits him, but on the contrary, it proves this for the classical theory of teleportation, and it works locally. Now, ladies and gentlemen, before I get into anything major, this is exactly what they had problems with the first time that radios, were made. That radio waves could only be given a short distance, like I think it was like 10 feet or whatever. And they said it was never practical that it could go across the room or, for that matter, down the street. And within 10 years, we had a global radio transmission system. So they said this, you can't do it for nearly every single experiment done. So where they actually do this is they encode the information to a particular particle in the light, and it basically rides with that particle through the light, or the particle strand or whatever it is, and it basically guides it through the laser safely. Supposedly, this actually works. So I guess that would actually work, because if you're basically taking the particle that's being sent and you're coding it like you would HTML, and you're sending that information forward, well, that superposition already exists. For those photons and various other particles already have their codons and how to move through that strand. They're not going to bombard each other or anything else. They're just going to continue directly until that stop is issued and that information is retracted. Now, the funny thing about this, ladies and gentlemen, is they did not say that they were able to retrieve the information. I find that very, very difficult to believe, but they wouldn't even bother to say that they could not retrieve the information once it was sent. And I wonder if they were able to retrieve it, even if it was a distance of 3.5 inches. I wonder if they developed the technology where once they put the information onto the particle, if they were able to actively down the road, let's say half a foot, 2 miles, whatever it was, get that information and from that laser and extract it. Because that would prove that not only could you teleport an object, but that you could actually transmit the object, and the object in question being the information they sent would be the actual element that they sent and not just a relative copy. And that they could actually retrieve that same information, and that it was not just a copy, but it was the exact same. And I wonder whether or not they even bothered to include that in the review. That would have been my question. Thanks, everybody.